Good afternoon, everyone who has joined. Very much appreciate making time for this webinar. My name is Craig Barr. I'm the Programme Director for the County Council's Digital Infrastructure Programme and also running the England's Connected Heartland programme, which we will talk through in the course of this slide deck. So what we hope to get out of today is to give you some insight into what is coming to Harwell by way of what we're calling a mobile private network. I'll give you a little bit of a background as to what that means. I'm going to assume a relatively modest amount of knowledge, so we'll be going through some fairly basic stuff as well. But most importantly, to try and explain what the potential is for enterprises and organisations on Harwell Campus. I will say at the outset, anybody who's got any questions, please pop them into the chat. And anybody who has any further, any wish to communicate with us further to find out more, we are absolutely very keen to engage in any collaboration around what this project is going to deliver at Harwell. First thing just to call out is England's Connected Heartland is a programme that's been set up on the back of a funding call from DSIT back in 2023 for something called 5G Innovation Regions. The problem statement behind that funding call, the rationale for it, was the relatively low adoption in the UK of, we can collectively call them advanced wireless connectivity. In most cases, really what we're talking about here is 5G, and in particular private 5G, mobile private 5G networks. It's a collaboration. The clue of the title, it being an innovation region requirement, DSIT were not looking for bids from individual local authorities. They wanted to have a consortium approach. And unsurprisingly, we collectively pulled together the authorities between Cambridge and Berkshire. So 9 other local authorities led by Oxfordshire, which approximates the Oxcam corridor, which seems to be a good synergy. And the whole intention of this is to create a network at Harwell for the use of private 5G connectivity to enhance the capabilities of the campus. It's also worthwhile saying that we as a programme are also delivering a project in the transport sector where we're commissioning a network, a 5G private network along the new section of East West Rail between Bicester and Bletchley, aiming to improve passenger connectivity. But obviously this call is all about what's happening at Harwell. So why Harwell? I mean, I didn't mention this. It's the sector that applies to the funding bid that we pushed in was against advanced manufacturing / R&D. And frankly, if we can't find good use cases to demonstrate how a private 5G network would enhance, improve productivity and collaboration capabilities at a place like Harwell Campus, then there isn't a case to be proven. So Harwell, lots of very data intensive workflows, a lot of collaboration, international collaboration requirements, and a mobile private network, as we will see, is a means of being able to resolve that without the upfront cost of individuals, enterprises at Harwell having to make that upfront investment, not being certain as to how viable or how good or how useful that network service might be. So what is being delivered? 5G standalone mobile private network. The standalone is a relatively important thing. Many of you may or may not know, I don't know. But standalone is utilizing a 5G core network as well as a 5G access network. And to date, most of the UK deployment, although it is rapidly changing, but most of the UK public networks badged as 5G are 5G radio access networks, but utilizing a 4G core. And a standalone network is simply faster. It's got much less latency and can have much higher throughput. So the standalone network is a full 5G end-to-end network. And private obviously means it is not on the public network. You can't access it through a Vodafone SIM or an O2 SIM. It is bespoke to Harwell. It's been a 2-year project in the making. A lot of work has gone into the preparation for this, but we are expecting to get the network live sometime during July 2026. And worth calling out as well at this point that we have secured funding for 3 years of operations. That's a managed service provided by Vodafone, and we will make sure that that's sustainable for a minimum period of 3 years. And we'll touch on the commercials and how that might work in a minute. Coverage, we initially started the planned deployment looking at using rooftops across the campus. But for a number of reasons, not least of which being the constant evolving of the estates at Harwell Campus, it became quite apparent that that was risky because we wouldn't know whether something that was good today might become obscured by a new building going up in 2 years' time. So we've elected to use lighting columns, 13 at this point in time. There is the potential for more to extend this network more into the STFC part of Harwell Campus. We're just needing to secure a way of the lighting columns on the STFC part of campus operate in a different way to the ARC section. But the coverage map there is an indicative view. Green is obviously excellent coverage. Amber is good, reasonable coverage, and red means little to no coverage. And obviously, a lot of the red blocks that you're seeing there are the actual physical buildings themselves, where inside coverage is going to be limited by the walls. It is worthwhile saying that indoor provision can be managed and provided, but there would be a cost to that. If somebody needs to have a 5G internal network built, then we can arrange for that to be delivered through the Vodafone contract. But there would need to be some funding provided for that purpose. So that's the coverage map as it stands at the moment. Once we have the thing deployed, we will have a much clearer idea as to exactly what that coverage will look like. As I touched on, I mean, it goes without saying that a private network is exactly what it says in the tin. So you're able to control how the network is used. It is much more secure than a public network can be. And ensures that services which are running across it can be depended upon for consistent performance, meaning that critical applications and business services can safely use that network, not wondering whether in the next 5 minutes there might be an outage or a go slow moment on the network. I will just say that I've been to Harwell several times, and the existing standard MNO coverage is pretty poor. This will be a real significant game changer, even in terms of its most basic, just access to connectivity perspectives. So it can be used for devices, handhelds, mobiles, but also for machines, for machine-to-machine connectivity, and sensors, and so on and so forth. Anybody who can reach the network will be able to use the service. The initial proposition is it'll be free for a period of time for anybody who wishes to use it, and we will be developing what that longer-term commercial model looks like to make sure it's sustainable beyond the period for which we are funding that ongoing service operation. But basically, more or less anything which is 5G capable will be able to connect to the network either via an eSIM or a separate physical SIM which can be inserted. It's a managed service provided by Vodafone. Important to state, it's not end user support, so we can't have everybody who's using the network at Harwell phone up Vodafone to say I can't get a signal at this point, so I need to have an extra device added to the network. That will need to be triaged initially through our team at the county council, but also with the estates and ARC team as well to help do that triaging. But once the network is live, we will be advertising it as being live, and people will be able to access the network as soon as they wish. My colleague Reese is going to dive into some really good use cases in a minute now. We are at the moment anticipating that the initial uses will be relatively modest in aspiration. They will be for things like movable CCTV cameras around the estate, potentially some parking applications, asset tracking, asset management, and any other kind of site operational requirements for the campus. But the aspiration is that we'll be able to start diving into some of the real productivity gains for the individual enterprises in the clusters around in the 4 clusters around the campus as well. These will take time to develop, I suspect, which is why we're making sure that the network will be available for at least 3 years to allow for people to understand how it might be able to be used, and how, in the extreme cases, there may even be a need for individual investments in technology at a local level, business level, to augment how operations are conducted using a private 5G network as well. So new digital capabilities across Harwell. It's a test bed for us as well. Very important to make this point as well is we do wish to be able to provide back to DSIT some decent case studies over the next 12 or 18 months that speak to the benefits of a 5G private network, and why next time round we would be able to get this built without there being a significant amount of public funding put into pump primers. So any collaboration with individual enterprises at Harwell for what these use cases might look like would be very, very much welcomed. So I mentioned about deployment being underway. It is due for completion by July. We have some dependencies in there about securing some license agreements for hosting of the core network, and a final piece of the jigsaw puzzle is agreeing specific licenses for the lighting columns. But once they are out the way, the actual build of the network should be reasonably fast, and we're reasonably confident that July will be a sensible launch date. I mentioned about 5G innovation regions and working with DSIT. The idea here is that we can replicate what's happened at Harwell in a year or two's time to prove that the other campuses of a similar type across the UK, or first of all across our region, but then across the UK as well, would be able to extend this capability without public funding, as I mentioned as well. And really, a modest objective here would be that this becomes replicated more widely across the Oxcam corridor for other science places like Westcott up in Buckinghamshire and others. Right, that's a very quick run through of an outline of what it is that's being built and how the timeline will work. Reese, I'm going to hand over to you to take control for your session about some proper use cases, please.
Yep, sure. Thank you, Craig. Right, I think I've taken control. That looks like I have. Good afternoon, everyone. So my name is Reese Simmons. I am a co-project manager on the 5G Science Innovation Campus project on behalf of England's Connected Heartland. My other co-project manager, Anna Miles, is on this call. I can see her. She's joined as well. So we're working together with Vodafone to deliver this project. Apologies, I am slightly nervous, and I am working between 2 screens. So if I happen to be looking off to the left, that's just because I'm using my second screen next to me. So what I'm going to do first is just start by talking about the simple use cases. So the use cases we're going to share, and I'm going to share in a moment, are your much larger, your aspirational use cases. It's where some of the use cases that could be developed over the next few years. But to highlight what Craig mentioned earlier, that the network has some, there's some very glamorous use cases that it can create and demonstrate, but it can also demonstrate and be used some very basic uses. eSIMs in mobile phones or tablets or laptops or physical SIMs, just to extend connectivity outside of buildings. I was sat in the Harwell car park a couple of months ago trying to send an email without a photo attached or any big attachment, and it was taking ages just to send that one email. The simple thing is that using the network's coverage will extend that. So where there is coverage from the network, you'll be able to send small emails, have large video calls, share large files without any problems. And then you've got things, as Craig mentioned, like CCTV, so SIM cards that go into CCTV cameras to allow mobile CCTV around the site, push to talk, sensors, whether it's heat, movement, Environmental monitoring is another example, and another very simple one is Wi-Fi. So what you can actually get is a little receiver that mounts on the outside of the building, because the 5G network will only penetrate so far within the outer skin of the building. So you can get a little Wi-Fi receiver that sits on the outside of the building, sucks in that 5G, and then you have a router in the office or in the warehouse or whatever it is, and that will project Wi-Fi then using the 5G network as the backhaul into that space. That could be used for long term, it could be used for short term, it could be used on a construction site to connect offices. And those are just some of the really basic day one use cases that this network can provide without a huge amount of investment or spend or outlay at that point. So, and there are other use cases there that I also haven't mentioned, but they're some of the simple examples and what this network could provide from the moment it's live. Right. So moving on. So man freight and 5G enabled smart logistics. So apologies, because I know the projects on Harwell really well, and some of these basic use cases, these bigger use cases I've had to I've picked up along the way, but I'm going to be reading from some notes as I work through some of these use cases, just because I'm not that much into the detail with what they've been delivering. So man freight. So although man freight work in logistics, the challenges they face are very similar to those found in advanced manufacturing and on large sites. They used 5G as a reliable on-site communications network to improve how vehicles, goods and people move around safely and efficiently. In simple terms, this meant systems could talk to each other instantly, cameras could automatically spot issues, and vehicles and assets could be tracked live across the yard. The result was smoother trailer movements, fewer delays and better safety. The same benefits apply to manufacturing and science campuses that rely on timely deliveries, accurate stock handling and close links between warehouses and production or lab spaces. So you might find some of these use cases are very relevant to your organization or an organization you're working with on Harwell, and some of these might not. So we've tried to really gather a bit of a wide variety. So this is Queen's University Belfast and 5G in AMIC construction. So this is actually a project that was part funded by 5G innovation regions. So this is actually been partially funded by the same funding stream as the 5G Science and Innovation Campus project here on Harwell. So this example comes from construction, but the lessons are very relevant to advanced manufacturing. It shows how a reliable, high-capacity on-site network can support real-time monitoring, automated equipment, and remote oversight. At AMIC, connected sensors, drones, and scanning tools were used to give a live view of what's happening on site. This means issues can be spotted early, progress can be tracked accurately, and decisions can be made based on real-time information rather than reports after the fact. The same approach applies to factories, labs and test facilities, where understanding what is happening across the site at any moment is critical. While this use case focuses on building an advanced manufacturing facility, it highlights something more important. If these technologies can help design and construct a complex site, they can also support safer, more efficient day-to-day operations once it is up and running. Another element of that is also a digital twin. So you've got a live digital twin where you could, walk around the building using virtual reality in real time and see how pieces of the puzzle form together. That was another element that came out of this project as well. Another one. So this is Belfast Harbour using private 5G network to digitalise operations. This was already in existence before the 5G Innovation Regions funding, but it is also another project that benefited and had additional money from 5G Innovation Regions in order to develop and expand the 5G mobile private network and its capabilities in Belfast Harbour. So the challenges are very, very similar to those found on large industrial and science campuses. It shows how a reliable on-site network can support remote monitoring, connected vehicles, and better oversight of valuable equipment. At Belfast Harbour, sensors and cameras are used to keep a live view of heavy machinery and cargo handling. This helps teams spot issues early, plan maintenance to prevent breakdowns, and keep operations running safely and smoothly. The same approach applies to manufacturing sites and campuses like Harwell, where engineers, inspectors and safety teams move around large, complex environments. Having access to live information on the move helps people work more effectively and make quicker, better informed decisions. Overall, this case shows how connected technologies can work together as part of a wider smart site approach, linking equipment, vehicles and environmental data in ways that are just as relevant to advanced manufacturing and research operations. And I know one of the future use cases for this network is they have the big hoppers in Belfast Harbour that loading trucks with aggregate, sands, other elements, and what they're actually looking to do is automate those. It's currently a very high risk procedure, running the hoppers, loading the trucks. So they're actually looking to use sensors and cameras. So that's all done in an automated fashion, so that removes the health and safety risks that come with operating the hoppers, but also smooth and streamline that operation. But that's kind of how the network is growing and some of their future thoughts, despite having very good uses for the network as it currently stands. So moving on to Worcester Bosch. So Worcester Bosch is a great example of how 5G MPNs, mobile private networks, deliver real practical benefits on a live production line. The lessons are directly relevant to science and innovation campuses like Harwell. So Worcester Bosch built the UK's first factory using a dedicated on-site network to support smarter manufacturing. So this allowed engineers to see how machines are performing in real time, spot problems early, and fix issues before they cause disruption. The factory also uses connected safety systems that help prevent collisions, creating a safer working environment for the staff. Importantly, all of this was introduced without major changes to the building or stopping production. New capabilities were added while the factory kept running. For businesses at Harwell, this is a practical example showing how an on-site 5G network can improve efficiency, safety, and resilience in day-to-day operations. So let's take a look at how their factory works in practice. So we've got a video coming up. So this is where we're hoping it works and you can hear the sound. So let's see. So that was a short video on the Worcester Bosch use case or case study. So I'm going to move on to the next slide from here. So this is the European Space Agency and partners and space-enabled 5G, which is something that's really heated up over the last year, and you may have heard about in different news articles. But just to talk about how that, how that could impact Harwell and some of the positive elements to that. So in 2025, the European Space Agency and its partners showed that this technology doesn't just come from mobile mass, it can also come from space. Using satellites, they demonstrated that devices can stay connected as they move between satellite coverage and ground-based networks without losing the signal. What this really means is more reliable connectivity, even in places that are remote, temporary, or hard to reach. Instead of connectivity dropping in and out, systems can stay online wherever teams are working. For space-focused organizations on campus, this opens up some very practical opportunities. It could support continuous connectivity for satellite testing, remote research equipment, and teams working away from the main site, as well as future autonomous systems. More broadly, it shows how these networks can underpin new space-enabled services, from connected services to globally linked research tools, supporting innovation both on campus and beyond. I think the space-enabled 5G is a very exciting development that's happening currently within the industry, for science and innovation campuses, and for some of those potentially most rural areas that have some real connectivity challenges. So moving on to Centrica, so a 5G-ready MPN, or mobile private network in energy. So Centrica's gas plant in North Yorkshire was the first of its kind in the UK to use a dedicated on-site network delivered by Vodafone, who are also the delivery partner for the Harwell project, as Craig mentioned. The key point here is reliability. Instead of relying on standard Wi-Fi, the site uses a secure, high-performance network that can handle large numbers of connected systems at once. This allows thousands of sensors across the plant to monitor equipment in real time, helping teams spot issues early and reduce downtime. It also improves safety. Workers receive instant alerts if there is a risk of gas exposure, and engineers can carry out inspections remotely using handheld devices rather than entering hazardous areas, demonstrating how a dedicated on-site network can support safer operations, better asset management, and a more connected, future-ready environment. So that's an example within a gas plant. So we're now going to talk about Toshiba and quantum secured private 5G networks. So this case study demonstrates two things that matter a lot on science innovation campuses: reliable connectivity and keeping sensitive data secure. Toshiba combined an on-site network with advanced security to show how real-time operations can be carried out safely. So using the network, engineers were able to control a robotic arm remotely while watching live video without delays or interruptions. So this shows that complex, time-critical tasks can be carried out from a distance. What makes this particularly important is the level of security built in from the start. The system was designed to protect data not just today, but well into the future, even as computing power continues to increase. This demonstrates how a dedicated on-site network can support secure collaboration, protect valuable research, and allow advanced tools such as robotics and remote instruments to operate smoothly across a large site. I'll move on to the next case study here. So this is a bit of a sector snapshot for pharma and life sciences, which we're very aware has a large presence on Harwell. So in the UK, pharmaceutical and life science manufacturers haven't widely adopted private on-site networks yet, but the opportunity is significant. Many of the challenges they face, maintaining quality, meeting strict regulations, and running highly controlled environments, are exactly where this technology can add value. A dedicated on-site network can support real-time automation, enhanced training, and more accurate quality checks. For example, it allows machines and sensors to respond instantly, supports immersive training tools where access is restricted, and enables rapid analysis of high-resolution inspection data to help maintain production standards. It can also support safe movement of materials using autonomous mobile robots in clean room environments, and provide the constant flow of data needed to optimize digital models of complex manufacturing processes. These capabilities are not theoretical. They are already being demonstrated in the UK's 5G Factory of the Future testbed, where real-time remote operations, live inspection, and flexible automated workflows are being tested in regulated environments. It shows how this approach could support the next generation of pharmaceutical and life science manufacturing as adoption grows. This segues very nicely into the next slide. So this is the AMRC Northwest 5G Factory of the Future. So just to elaborate a little bit more on this testbed, it's a real working manufacturing facility in the UK, set up to support highly regulated industries such as aerospace, medical devices, and pharmaceuticals. Its purpose is to show how advanced connectivity can work safely and reliably in environments where precision and compliance really matter, and demonstrates practical capabilities that are directly relevant to life sciences and health tech manufacturing. These include remotely operating robots with live visual feedback, carrying out fast and accurate quality checks, and moving materials around the site using autonomous systems. The key enabler is a highly reliable on-site network that allows information to move instantly between machines, systems, and people. This supports live monitoring, predictive quality checks, digital models of production processes, and flexible layouts that are difficult to achieve with traditional networks. For health tech companies based at Harwell's, this provides a potential blueprint. It shows how compliant, precise, and scalable manufacturing environments can be supported by modern on-site connectivity, helping sites adapt and evolve as requirements change. So a little segue between those two there. So moving on now, so that's the end of the kind of end of our case study. So we mentioned it on each one, but why these, the use cases that we've mentioned, those case studies transfer to Harwell. So the same challenges, different location: automation, logistics, data flow, and safety. Technology drives relevance: robotics, IoT, computer vision, digital twins, remote operations. Proven low risk blueprints, adapt what works elsewhere to your use cases. And the case studies we've shared here are just a small number of a vast array of use cases. Since we've started this project 2 years ago, 5G mobile private networks have become hotter and hotter and hotter, and the adoption is growing quite quickly. And in that, case studies and use cases are starting to flow. Different ideas, different ways of using the networks are all coming to the forefront. So the picture we see now is evolving rapidly in a very exciting way. And it's been great to kind of be part of this wave as 5G mobile private networks, become a technology for now and into the future, and people are adopting them. And it's a really exciting wave to be riding at the moment. So the opportunities of the mobile private network. So we hope these examples have sparked ideas. The aim isn't to copy them, but to show what's possible, so you can start imagining how similar capabilities could support your own network. So digital transformation across industries, economic growth and innovation, social value, and reducing digital inequality. And that is the end of my part of this presentation. So I believe now it's over to the Q&A. And is there any Q&A, Rosie, that we have at the moment?
I'll just check the Q&A. Thank you, Reese, and thank you, Craig. That was a lot of information. And so if anybody, and it's my fault because I'm the communications person, so I can't blame anyone but myself. But the idea here is to show everybody on the call what exactly is possible with this technology. And the answer to that is so much. It's vast in terms of what we can do. And so we've got a lot of different people from different organisations at Harwell on the call. I think it might be worth as well just saying a quick hello to our partners at Vodafone. So Chris Bridgman, who is our MPN representative, is on the call. So Chris, if I just allow your mic and camera, might be able to say a quick hello.
Not to put you on the spot or anything, Chris.
Put you on the spot,
no,
definitely.
hello.
There we are.
Good afternoon, everyone.
Welcome everyone. So Chris will also be able to help us answer any questions if you have a slightly more technical question, if you have any. But really, I'm really pleased that Reese, you picked up on the fact that there are some really immediate quick wins in terms of how the MPN can be used, and then there are also these much bigger opportunities logistically and in terms of safety across the campus. So yeah, Chris, I'm not sure if you have anything on the spot to add to our presentation today.
No, look, thank you all for attending today. I would just re-echo a few points made today, right? This is a fast evolving technology platform within a multitude of verticals, right? And what it's doing is it's fundamentally changing the way that people look at networking. Cellular networks are something that we as consumers all depend upon, but they are now playing a really massive part in the industrial evolution. So we're seeing large global organizations adopting private 5G to fundamentally underpin the way that they adopt new digital services and adopt new technologies. So as Craig said, this is a platform to allow people that operate within Harwell to gain advantage from a network that's already in place. And I would massively encourage people to do so. It's a fantastic technology that is really making impact across a multitude of different verticals.
Yeah, brilliant. It's
Thanks,
such
Chris.
a wide range. Thank you, Chris. It's so in terms of the content as well, you will have seen today, we tried to give an example of general examples of where 5G MPNs are being used successfully, but also relevant ones for the clusters at Harwell, because Harwell has the space, energy, quantum clusters and health tech. And for the pharmaceutical slides, the reason why we didn't give any examples of that so far is that it hasn't actually been adopted in the UK yet, but research shows that this industry is really keen on adopting. So this is a potential for pharmaceutical companies at Harwell could potentially be the first in the country to adopt, which is really, really exciting if they were able to be part of a case study there. So just to touch on that, we've had a few questions come in. I believe we've got our friend Ashley from the Space Cluster. Hello, Ashley has said, have you been working with ESA XSAT's 5G, 6G lab at Harwell? And if so, what kinds of innovation do you see this private network enabling or supporting going forward? Great question.
So the short answer, if I may, is to say yes. We have been working with Antonio Franchi really from the get-go from the project, obviously cognizant that Vodafone under a separate contract provide them with a small network within the ESA building on Harwell Campus as well. And we're very much looking to facilitate some of the potential test beds and trialing of technologies utilizing the lab environment at ESA 5G, 6G lab as well. And in terms of innovation, the take obviously there is about convergence of fixed and terrestrial and non-terrestrial 5G. I have to say I'm not close enough to the possibilities of that one, but we're very much open to further discussions with Antonio and his team. I don't know, Chris, whether you wanted to put a Vodafone flavour on that one.
Yeah, look, I think satellite is a massive evolving area. You know, Vodafone is heavily investing in direct-to-device satellite for our public network. We've obviously been working with ESA in the past. I think it's understanding where satellite fits into private 5G. So we're doing a number of projects where satellite is part of the backhaul, but I know that we're also looking at where satellite fits in between the core and the radio, and we use it for other opportunities. So it's very much an evolving part of private 5G is satellite for sure.
Perfect. And our friend James from the European Space Agency has dropped a comment. And Chris, thank you for your response there, saying, is there a way for industry or local Harwell campus stakeholders to suggest use case demonstrations? And I think all of us would give a resounding yes. We definitely want to hear what your ideas are to help your businesses, to help your work. So it's not just security and monitoring, although those are very easy kind of implementations. Ultimately, this network is there for you to use to improve whatever operations you want to in your business. And so if anybody does have an idea and wants to come to us, we will have our email contact address on the last slide for you to contact us. And we also have a contact form on our website, which is at the bottom left of the slide on screen. England's Connected, heartland.co.uk. So if anybody wants to reach out to us with something that's not really a standard implementation, but something that's unique to their business, we definitely want to hear those. And also, will there be any plans to integrate with existing Vodafone 5G MPNs on campus? I think we have looked into that, haven't we? Craig, would you like to add a bit about that?
Yes, I mean, so in principle, Vodafone providing the campus-wide 5G MPN and also being responsible for delivering the contract for ESA, logically there would be a way of incorporating those or amalgamating those. And we've had some initial discussions with Vodafone, but Chris, I mean, it's quite complex, isn't it? There will be several considerations, but yes, the goal would be, I think, from my perspective, to see what could be done to blend those services. I mean, it is complicated by different contracts having different service levels, different renewal dates, different contractual terms, and so on. But in principle, yes, I think, Chris, I don't know whether you wish to comment.
Yeah, look, I think it's a question of what are each of the networks being used for. The ESA network is very much heavily being used for testing. You wouldn't want to do that on a publicly available MPN that runs across the campus. So there could be an opportunity for them to run in parallel. One is providing services that are outside of the testing. So it's something we're very much looking into. But yeah, interoperability between the two is going to be a big challenge. We may have to decide which one does what and how people consume it.
Great. We've got another question in the chat from Erica, and she says, can you briefly introduce the process, costs and timeframes of testing and evaluating the new Harwell MPN with our own IoT plus AR technologies? And she said, sorry, I've missed the first part of the webinar. Maybe you have explained this. Erica, we haven't explained that just yet, but we can circulate the slides afterwards and the recording. But yeah, in terms of the process, cost, timeframes of testing the new Harwell MPN with existing technologies? Is the question there.
So I can address the testing element of the network itself, and so we'll complete some thorough testing of the 5G MPN itself once build is complete in July. So that's about a month to 6 weeks worth of testing, just to test the radio, test the capabilities, test some of the baseline use cases. But in terms of an organization by organization basis, it will be a discussion around what you want to use and how that could be integrated into the network itself. Chris, you got any thoughts on that element?
I have a number of thoughts on that element. I think it's it's a fantastic opportunity for everybody, right? AI we see as AI, IoT, augmented reality, they are all critical parts of what we're trying to do with MPN, right? They are critical technologies that, let's call them traditional industries, are desperately trying to adopt and struggling to do so. So I think it's a really important topic that we should absolutely address for sure. Love to do that.
And the key thing is this network it will be providing largely, outdoor coverage and cover a variety of use cases. If organizations have individual bespoke use cases that they would like to use the network for a certain thing, that would, it would be a discussion to talk about it before, to understand what you need from the network, and are there any adaptations or provisions or updates or upgrades or alterations need to be made or expansions need to be made in order for you to, for that network, for your use case to be able to be facilitated, in essence. So sometimes the network can do a lot of things, but it might need some alterations in order to adapt to specific use cases, particularly when it's indoor. Obviously we're building a huge amount of outdoor infrastructure. If it's going to be a large indoor network, and we have had a few organizations have conversations with us, Diamond Light Sources is one example around what an indoor 5G private network would look like. It's then expanding that network from our outdoor network to the indoor. Good news, it's a huge amount of infrastructure we're laying down, fiber and radios across the site, which are getting connectivity to buildings, to the outer skin. But if people want something that covers the whole inside of a building, that's a conversation around what that element would look like and the commercials around that.
But I think it's fair to say that the cost benefit would be easier to justify as a business case for standing up an internal 5G network by removing the cost of the core infrastructure and backhaul network that is provision as part of the network that we're building in principle. So it should be, and that's really one of the things that we're hoping will happen here, is that over the course of time, those deep dive use cases into really what the business case would look like for justifying an investment in an internal network would be easier to make, would be easier to pull together by having a network presence on the campus in the first place. Chris, I don't know whether you would choose to correct me on that one.
No, I completely agree.
Okay.
Right, and so we can pick that up with you if you'd like and look at that further. But I think once the network is up and running, then we'll be able to help any businesses with their specific needs more directly. So do get in touch with us. And I think we've said July, isn't it, Craig, for the
yes,
live
but it'll
gate.
be an interesting. I mean, I really do wish to embellish this point. So there's been a lot of hard. This has been a very hard, genuinely the hardest project that I've ever been responsible for delivering. for any manner of reasons, but actually the hard work in a different guise starts once the thing's deployed, which is helping to really get people over the line to understanding what those benefits are. I mean, Reese presented some fantastic use cases, but they're just scenarios in different, in different parts in different parts of the country. We really want to be able to put some time and effort into extending what that could do at Harwell Campus, and it's a very exciting opportunity. But we are expecting to be significantly involved, certainly for the next 12 months, in that engagement with people at Harwell. We would really be delighted to have any requests for meetings or collaboration or ideas. We're even loosely thinking about setting up some kind of a working group, a telecoms working group, or a connectivity working group across Harwell, which I don't think exists, to help us flush out what some of those use cases might look like.
This actually leads in really well to our next question, Craig, because Ashley says, looking at the case studies, many of the benefits and use cases seem to come from indoor private network deployments, often tailored to a single organisation. In a multi-organisation environment like Harwell, how would this work in practice, and what would be the process and cost for different organisations to deploy private 5G within their own facilities, such as clean rooms and pharmaceutical labs?
I mean, the only bit, Chris, which I can't comment on there, which I would lean into you for, is I'm assuming there is separation of what I'm going to call like closed user groups or individual entities able to access their own part of the network in a secure fashion. So although it's one set of physical infrastructure, there are logical ways of separating up those networks for individual businesses to be treated as if they were standalone businesses. Chris?
Correct. Yes, we can absolutely segment the network to provide that private aspect across the private network. So keeping traffic independent, keeping separation, both physical and across the network. So that absolutely can be achieved with the MPN. That is very much a principle of why it's so important for Harwell.
And that really was the whole principle behind this, was rather than having individual enterprises need to stand up their own MPNs, why not put a campus-wide network in place and then allow it to be finessed to suit the requirements for any individual use cases requiring indoor coverage.
Great. Okay, we've got another interesting question from Natalie. She says, have you looked into drone testing in Harwell and how the MPN can be used for that?
We have considered drones, and we've also looked at Darwin, and there's been a discussion with Antonio, I think, around whether we could maybe augment what the driverless vehicle how that could be augmented or improved with the use of 5G standalone 5G MPN connectivity. But indeed, drones. I mean, it was a speculative view when they were building the Reading to Coventry and Cambridge drone corridor, Project Skyway. There was an opportunity for us to be able to help them pilot some drone testing on the 5G network at Harwell because of the proximity of how that network works. So I think the answer is yes, absolutely. It's one of the things we need to develop. We just haven't had a chance to drive that forward yet. Yes, Westcott, Ash, as well, indeed.
Yeah, great. So hopefully that's answered all of your questions. Please continue to drop the questions in if you'd like any clarification.
Or do use the mailbox, that ECH mailbox that Rosie. I think are we aiming to distribute these slides via a PDF or similar?
Yes, we can. Yeah, we can.
And the contact details are on that as well.
Yeah.
So
certainly.
we're contactable is the point.
Yeah.
There have been a few questions around just mentioning commercials, so that's something we're still working through. There's a separate team that are currently working through those commercials and what those will look like. I think Erica said, cost of 2 SIMs potentially, and obviously there's the question around, potentially installing a 5G MPN within a building. So in terms of the commercialization element of the network, that's bits we're currently working through, but we want to have that all in place, but obviously by the time the network goes live. So that's something we're currently focused on.
Yes, I mean, it's a really important point, Reece. So, I mean, I'm being completely transparent. What we're aiming to do at the end of the first year is to secure sufficient interest and take up of services for the thing to be self-sustaining from year 2 and 3 onwards, ideally. But in the interim period, we are rightly or wrongly considering this as being a, for the native network that sits there and provides services. This will be free for a period of time, whether that's 6 months or 12 months. I'm not entirely sure, but the idea is we don't want to put barriers in the way. We really want people to climb onto this, start finding use cases, and that will help us understand in an iterative fashion. This is your network at Harwell Campus, guys. This is something that we've facilitated and are funding, but really we need to find a way of optimizing how the commercials work. And I think the easiest way of doing it initially is to provide it as a free service for a period of time, and then we'll work through the commercial model as we are moving through that period.
And I think this is a long-term thing, isn't it, Craig, which you touched upon earlier? How long do you think this will be available for?
So look, we're underwriting our program is underwriting the cost of the service operation. Let's call it for what it is, for 3 years. Ideally, we don't want to need to do that. We would like to be able to pull some of that revenue back in to allow us as the program to pump prime further opportunities. I mean, Westcott or others indeed in the England's Connected Heartland region. So the more money we can bring back in to fill the pot for the 2 million capital and ongoing service costs for this, the better it is the better it is for the region and certainly for Oxfordshire. So I'm sorry I'm not answering that question directly, but yes, it'll certainly be available for a minimum of 3 years, but we'd like to think that it'll extend well beyond that one. The contract itself, that's an important question, is a 7-year contract with break points in it at year 3.
Yeah.
I should say as well, just to add one other dimension, it's a framework contract with Vodafone, by which I mean, should the whole thing work out as well as we hope it to, then Westcott and any other kind of enterprise, any kind of campuses of a similar nature would be able to use that same contract without necessarily needing to run through their own procurements to build a thing. So as a community of UK PLC, advanced manufacturing, research and development, innovation, this is a really good way of us trying to collaborate for success.
I was just going to add in on slightly separate note. I can see we have quite a few STFC colleagues are on the call, and obviously it's an area that currently isn't fully covered by the network. Craig kind of covered that earlier, but just to give a kind of a brief update with we're still planning to build STFC. We were planning to build it along with the ARC section of Harwell. The ARC section of Harwell is using lampposts, and we were looking to use the lampposts in STFC, but STFC have powered their lampposts differently. They're powered via a BMS system, which means basically they're dead by daylight and alive at night. And there was no separate power source available in those lampposts. So obviously, putting radios on lampposts, we require power there all the time, or a network through the night is not much use. So we've been working closely with STFC to understand what an alternate option is, and B, how we would then power that without disturbing and digging up a huge amount of site to run power cables. So when you saw the coverage map much earlier in the presentation, you would have seen that we've managed to get coverage down the main street of STFC past reception and elements. We've tried to place radios to provide as much coverage as possible when the moment the ARC section of the network goes live, but we haven't given up with STFC. We're working closely with the team to try and find locations that will provide good value coverage. When I say good value, I mean contiguous coverage that's worth using rather than continually dropping out in different areas and having black zones. We're working very closely to try and find locations that don't create disturbance to power and connect the locations up with fiber and provide good value coverage to the campus so that people would adopt it on the STFC section. So we are pushing on and forging on to try and make that happen. So it's just to provide some reassurance that we're still working away and working very closely with the team at STFC on that.
Great. Yeah, that's very helpful. Thank you, Reese. Okay, I think we are nearing a close. We've got 5 minutes left. Just wondering if there's any final questions. Anything that was unclear? No.
Good. Well, people can go and have some lunch.
Yeah, great. I guess we can close a little bit early then, if that's okay. Oh, thank you. Ashley says, great presentation. Thank you. Thank you all for spending your lunch break with us. It's it's your time, so we really appreciate that. And as I said, we will be in touch via email to circulate the slides and the recording. We'll try and get that on our YouTube channel as well to share with you and for anybody who couldn't attend. So thank you all very much. Thank you, Chris from Vodafone, our partners.
No worries.
In this project. It's a really exciting time. And Craig, if you just want to go on to the next slide for a moment, please, we could
Yes.
just share that,
that.
contact email, and we can contact you via this email anyway with the slides, but just in case you need it, there it is again. There's our website. And thank you so much, everybody. I hope you have a wonderful rest of your day.
Thank you very much.
Thanks very much, all.
Thank you.
Thanks, all.
Take
Thanks, guys.
care.
Cheers.
Bye-bye.
Cheers. Bye-bye.